Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions, equilibrium of a body, and Archimedes upthrust. This exercise was a previous one in the brevet exams in 2017 first session, exercise number 4. The title of this exercise is immersed volume. A wooden cube C of side A is equal to 2 centimeters. Then the side of this cube is given by 2 centimeters, knowing that centimeter is not the SI unit of length. In order to convert from centimeters to meters, we simply divide by 100. Then 2 divided by 100, then the side of this cube in the SI is given by 0.02 meters. Floats on the surface of water. So this is the cube C floating on the surface of water. Given that the density of water is given by 400 kilograms per meter cube, and the density of water is given by 1000 kilograms per meter cube. So here we have two materials. We have the wooden cube, and we have this liquid, which is water. Then we have two densities. 400 kilogram per meter cube corresponds to the density of the cube C, and 1000 kilogram per meter cube corresponds to the density of water. Now comparing the two densities, the density of water is greater than the density of wood, so we expect, or let's say that the density of wood is less than the density of water, so we expect that the cube C will float on the surface of water as shown in this document. Now number 1, show that the volume of C is V is equal to 8 times 10 to the power minus 6 meter cube, knowing that this cube is a regular shape and its volume can be calculated using the following formula, that the volume of the cube is equal to the side to the power 3. Now replacing the value of the side in the SI, so 0.02 to the power 3, then the side is given by 8 times 10 to the power 6 after plugging this on the calculator, knowing that the side is in the SI, so the volume V will be in the SI, which is meter cube. Then the volume of this solid is given by 8 times 10 to the power minus 6 meter cube. So here let's write that the volume of this wooden cube is given by 8 times 10 to the power minus 6 meter cube. Now number 2, show that the mass of C is M is equal to 3.2 times 10 to the power minus 3 kilograms, knowing that we have the density and we have the volume. The density, the mass, and the volume are related via the following formula, that the density is given by mass divided by the volume, knowing that we are interested in determining the volume. So constructing the triangle of this formula, here because we have divide, then rho will be at the bottom, M at the top, V here. We are interested in calculating the value of M, so putting our hand of M, then the mass of the wooden cube is given by the density times the volume. And here we must be very careful because we have two densities. Notice that we are calculating the mass of the wooden cube, so the mass of the wood, then density must correspond to that of the wood and not of the water. So the density of the wood, which is denoted by rho wood, let's here write as a subscript wood, is given by 400 in the SI multiplied by the volume that we already calculated, which is given by 8 times 10 to the power minus 6. This volume corresponds to the volume of the cube as well. Plugging this on the calculator, it will give us 3.2 times 10 to the power minus 3. Since both the densities and the density and the volume are in the SI, so the value of M will be in the SI, which is kilogram. Then the mass of this wooden cube is given by 3.2 times 10 to the power minus 3 kilograms. Now number 3, the cube is submitted to two forces, its weight W and Archimedes upthrust force F. So here, because the wooden cube C has a mass, then it will be directly subjected to the weight acting on the center of gravity vertically downward like this. And because we have a liquid, then it will be subjected to the other force, which is the Archimedes upthrust force F. So it will be acting on the wooden cube vertically upward. So what's the point of application of this force? It's the center of gravity of the immersed part. So this is the immersed part. So this is the center of gravity of the immersed part. Let's say that this is the immersed part. So F will act vertically upward on the cube like this. Now in 3.1, indicate for each of the two forces if it's a contact force or a force acting from a distance, knowing that the only forces that act at a distance are the weight, the electric, the magnetic. So the weight, let's say weight W, or it's enough, W is a force classified as acting from a distance. Whereas all other forces are classified as contact forces, and in particular the Archimedes upthrust force F. Then F is a contact force. And here we are in part 3.1. Now just a side remark, here they are telling me the weight. So this is the weight vector W. Now here, because we have a liquid which is water, then we have two weights. We have the real weight and we have the apparent weight. Now in number 3.2 they are telling me write the relation between the magnitude of these two forces. So in order to determine the relation between the magnitude of these two forces, we need to write first the condition of equilibrium, then we deduce the relation between the magnitudes. So whenever we are writing the condition of equilibrium, we always use the real weight and not the apparent weight. Okay, so I repeat, whenever we are writing the condition of equilibrium, we always use the real weight. Then let's say at equilibrium, so how do you apply this condition? Always on the left we write the sum of forces acting on the cube C, and they are given by the weight vector W plus F upthrust. And on the other side of this equation we write the 0, and we don't forget the vector because this is the vector equation. Now moving F to the right hand side or to the other side, we'll have that W vector is equal to minus F vector. And I repeat that this W represents the real weight and not the apparent weight. Now the first equation tells us that both weight vector and F vector acting on C cancel each other to give us the 0 vector, whereas the second equation tells us that both forces have the same line of action, opposite direction, and same magnitude. Since we are interested in the relation between the magnitudes, then let's say in magnitude, so here we drop down the vectors and we get rid of the minus sign, so the weight is equal to F. So this is the real weight and it's equal to M times G. Okay, so this is the answer for 3.2. And now in part 3.3, determine the volume VI of the immersed part of the cube. So we know that the volume of the immersed part and the magnitude of F are related via the following formula, that F upthrust is equal to the density of the liquid times the volume of the immersed part times G, knowing that we are interested in determining the value of VI. So we know the density of the liquid, which is given by water 1000 kg per meter cube. However, we don't know the value of F, and the G in this case is not given, so we don't know if we are performing this experiment on Earth or no. So first, let's determine the value of F from this equality, which is given that W is equal to F. So we know that in magnitude W is equal to F, but the value of W is given by that M multiplied by G. Then the value of F is given by M times G. So here we cannot determine explicitly the magnitude of F, so we cannot say that F is equal to M times G, and we know that the value of M here is given by, so we cannot say that F is equal to M times G, which is equal to 3.2 times 10 to the power minus 3 times 10, so F is equal to 3.2 times 10 to the power minus 2 newtons. This is wrong, because here in this exercise we don't know the value of G, so we don't know whether we are performing this experiment on Earth. So let's take the magnitude of F as m times g. So now in this case we know the value of F. Let's say that F upthrust is equal to the density of the liquid times the volume of the immersed part times G. We are interested in determining the value of VI. Constructing the triangle of this formula. Here, because we have multiply, then F will be at the top, rho L, VI, and G at the bottom. We are interested in determining the value of VI, which represent the volume of the immersed part. So putting our hand over VI, VI is given by the value of F upthrust, which is denoted by F, divided by the density of the liquid, which is denoted by rho water, multiplied by G. Let me make some space. However, here in this case, the value of F is given by M multiplied by G. So let's replace this F here. So M multiplied by G divided by rho of water multiplied by G. So here, as we can see, that the volume VI doesn't depend on G because we can simplify G with G. Then VI is given by the mass divided by the density of water. And for this reason, they didn't give the value of G as a given to be 10 newtons per kilogram. So the volume of the immersed part is independent of G. So for example, if we perform this experiment on Earth, and then we perform the same experiment on Moon, so the volume of the immersed part will not change. Now, the value of M is given by 3.2 times 10 to the power minus 3. Now I'm replacing the values of M and the density of water divided by the density of water, which is given by 1000 here from the given. Now plugging this fraction on the calculator, it will give us 3.2 times 10 to the power minus 6. Since everything in the SI, so the volume VI will be in the SI, which is meter cubes. Then VI is given by 3.2 times 10 to the power minus 6 meter cube. So now we have two volumes. We have the volume V of the total volume of the cube, which is given by 8 times 10 to the power minus 6 meter cube. And the volume VI of the immersed cube, which is given by 3.2 times 10 to the power minus 6. Now comparing both volumes, we can see that the volume V of the cube is greater than the immersed volume. And this is reasonable because now if we check this document, this is the total volume V of the cube, which is the outer volume that we can see. And the immersed volume is the one shaded here. So as we expect, that the immersed volume must be less than the total volume of the cube. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.